Hello, Luke. Welcome to lesson 46. So today we're going to be talking about conjunctions. And that means that we'll be kind of talking once again about inequalities. So first, let's just start out by getting the definition of what a conjunction is out of the way. So let's do that. So a conjunction describes a statement of two conditions, both of which must be met. All right, that's a definition that's basically taken directly out of your textbook. So let's give some examples here, and then that'll make that definition make more sense. But maybe while I'm writing this first one out, why don't you go ahead and write this definition in your notebook so that you can memorize what a conjunction is. And then I'll give us the first problem. So all right, so in the past we've talked about graphing inequalities. If I have something that looks like x is greater than 2, and I asked you to graph that on a number line, you would then draw your number line, and then you would put in some numbers on your number line. So maybe we'll put a -2, and then maybe a -1, and then maybe a 0 and a 1 and a 2 and so forth, 3 and so on and so forth. And then we have to show that x is greater than a 2. So we would then use a hollow circle around the 2, indicating that it can't be equal to 2, but it could be anything greater than a 2. So anything going forever in this direction, right? All right, and that's just review. So this is where we are taking a variable and we're putting one condition on it. And the condition is that it has to be greater than 2. But sometimes we might want to add a second condition to that variable. So let's say we're saying that x is greater than 2 and x is less than 10. Okay? So we're adding a second condition to the variable x. And that is what a conjunction does. All right, getting back to our definition. A conjunction describes a statement, and this is a statement here. X is greater than 2 and x is less than 10. And it has two conditions as opposed to the one condition that we're used to seeing, and both of them must be met. So it's not enough to just draw on our number line something that is greater than 2 now. We must also show that the x has to be less than 10. All right, so we'll extend our number line here. Let's say this is a 5, and this is a 6, and this is a 7. I guess I'll have to extend this just a bit more. So maybe let me just run that out this direction, and we'll add a couple more lines here. So we have 7, we have 8, we have 9, and then we have 10. Oh, 10. And then we have, maybe we'll throw an 11 in here and maybe even a 12 in here, just to complete a little bigger picture. All right, so what are we saying here? Well, x is greater than 2. Well, that we've already got graphed here. We're already showing that x has to be greater than 2. But we also need to show that x is less than 10. So if I were to graph x is less than 10, well, I would find the home for my 10 on the number line and put a hollow circle around it because, again, x cannot equal 10, but it could be anything less than 10 based on that second condition. So that means this condition says anything less than this is what x could be. So we're going off forever in this direction. So each individual conditions on their own can be graphed, but to graph just this whole expression where both of these have to be true, we need to graph or show on the number line where both of these conditions are true. So maybe just to kind of, I don't know, illustrate this a little bit more, maybe we'll just try to improve this a little bit. So x is greater than 2 is going to be anywhere from here on and on and on and on and on for infinity, off in this direction. That's all showing x is greater than 2. And then if we want to show x is less than 10, well, that means we have to start at the 10 hollow circle, and we're going this direction forever and ever and ever, forever and ever, off that way. Okay, so where is this whole statement then true? Where is this conjunction true? Well, it's true where we have both a kind of the greenish line and the red line. All right, and in that case, anything in this area would make the conjunction true. Any number that we select out of this area would make this conjunction, x is greater than 2 and x is less than 10, true, right? Because that satisfies both. If you're in this area, you're greater than 2, and if you're in this area, you're also less than 10. All right, but if you're outside of that, you're only going to be satisfying one of these conditions, and that's not enough for a conjunction statement. Both of the conditions must be met. Both of them, not just one. All right. So when you graph these conjunctions, you need to first kind of graph the one side of the conjunction, graph the other side of the conjunction, and then as your final answer, choose the overlap. Where are those two graphs overlapping? That's going to be the solution to the problem. All right. Okay, so moving on. Now there is another way to describe this condition here. X is greater than 2 and x is less than 10. It's kind of a shortcut way. And to do it, we just simply write x in the middle, all right? And we're saying that x has to be less than 10. That's the right side of that conjunction. But x also has to be greater than 2. So on this side, the left side, we have the greater than 2. So this is a way of expressing this statement up here without the and, all right? We're just stating it as 1x with 2 greater or less than signs. So we're showing what x is greater than and what x is less than, all right, with x in the middle. And make sure that this makes sense once you've written it. Sometimes it's easy to get mixed up, and then you might end up with something that looks like this. 2 is, something like this. Here, what are we saying? We're saying x is less than 2. Okay, that's fine. Then we're also saying x is less than 10. Well, okay, kind of makes sense. It's just a little bit redundant, though. If it's less than 2, obviously it's going to be less than 10. So this doesn't even really need to be here. Okay, so be careful. Sometimes these statements don't make a whole lot of sense. Another way to see that would be if I were to say x is, greater than 2, but x is less than -1. Now that one obviously would not work. X can't be greater than 2 and less than a -1 at the same time. That'd be saying that it's anything over here greater than 2 with a hollow circle, but it's also anything less than a -1. It's anything over here, which they can't be both. So be careful. Some of these conjunction expressions don't make sense if you don't write them correctly. So it's always good to kind of reread your conjunction expression and just ask yourself, does this say what I want it to say? X is greater than 2. Yep, that's what I wanted to say. X is less than 10. Yes, that's what I wanted to say. All right, so just be careful when you're writing those. All right, well, let's do a couple examples, and I'll take these directly from the book, and then you should be ready for your lesson today. It's a pretty straightforward lesson today. So the first problem they ask you to do is to draw a number line and graph the solution of x is greater than a 5, but less than a 10. Okay, so how would we graph this? Well, let's draw our number line, and we'll select some numbers to throw in here. We're looking at between 5 and 10. So maybe we'll just go, a 4 and a 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and maybe a 15. Okay. So how would we graph this? Well, let's just look at one side at a time. So x has to be greater than a 5, right? So we'll do that in maybe orange. So here's our 5. Hollow circle again because x cannot equal 5. It has to be greater than 5. So we do the hollow circle and anything to the right because it's greater than 5. So anything forever and ever and ever in this direction would be the solution to the left side of this conjunction. Now the right side of the conjunction says that x is less than 10. So how would we graph that? Well, we'll graph that in red. So we have x is less than 10. So here's our 10, and because it's not equal to 10, it has to be a hollow circle. And x is less than 10, so we have to go to the left here forever and ever in this direction. Okay? So where do these two graphs overlap? Well, they overlap right in here. Maybe I'll do a different color here. We'll do blue. They overlap from here with a hollow circle all the way over to here with a hollow circle. So this would be the graph. That would be the graph area. So if I then, just to clean things up, let's rewrite this graph, kind of showing what the solution graph would look like. So if we've got 4, 5, 6, 7, 8, 9, 10, 11, and maybe we'll just go up to 12. And our final graph is going to be, excuse me, it's going to be a hollow circle on our 5. So we'll do this in blue again. Hollow circle on our 5, hollow circle on our 10, and then the graph is going to be what's between that. All right, so this would be the graph of that particular expression, that statement, that conjunction. All right, very good. Let's try another one. So let's say I want you to draw a number line and graph the solution of a -2 is less than x, which is less than or equal to a -4, or no, positive, excuse me, +4. All right, let's do it again. Let's draw our number line. And we're dealing from -2 to 4, so we'll just start with a -3 to a -2 to a -1, 0, 1, 2, 3, 4, and we'll just go up to 5. That should be good enough. And let's take a look at the left-hand side. This is saying that x is greater than a -2. So we'll find that -2 on our line, and because, again, it can't be equal to -2, we have a hollow circle. X is greater, which means we have to go forever in this direction. And then if we look on the right-hand side, we have x is less than or equal to a 4. So here we do have an equal condition. X is less than or equal to a 4. So here's our 4. It could be equal to 4. So this has to be a solid circle, right? Because it could be equal to 4. If it's not equal to 4, it's going to be less than 4. So that means we have to go forever in this direction. Okay, and then finally, for our solution, we need to look at where those two graphs overlap. Where are both conditions true? So we'll just rewrite this real quickly. We have a -3, -2, -1, 0, 1, 2, 3, 4, and 5. And so what are we looking at here? Well, we're looking at a solid dot on the 4, a hollow dot on the -2, and then everything in between. This would be our solution. All right? So hopefully you see how that works. This one we had an example of a hollow circle on one side and a solid dot on the other, and that's because of this less than or equal. All right, very good. Let's try, maybe one more here. So this one, let's try it. Yeah, this is, we're going to write this in the opposite way. So instead of giving you the statement, I'm going to have you try to figure out the statement. So this is going to be, again, taken directly from the book. So they have an example where they say, write the conjunction that designates the numbers that, that are greater than -1 and less than or equal to 5. Okay, so here I want you to write the conjunction statement that designates the numbers that are greater than -1 and less than or equal to a 5. Go ahead and try to do that on your own, and then we'll do it together. All right, so we obviously have an x, and that would be the numbers that we're talking about here. And those numbers are greater than a -1. So what would be, well, how would we write that? X is greater than a -1. Remember, Al the alligator eats the bigger number, so he's eating the x because the x is greater than a -1. All right, and we're also saying this conjunction statement here, and less than or equal to a 5. So this x has to be less than or equal to a 5. Notice again, it's less than. So the alligator is eating the bigger number, the 5. All right. So this would be the conjunction statement expressing x as greater than a -1 and less than or equal to a 5. All right. Very good. Then we'll do one last one here. One other possible way that they could ask you to work this kind of a problem. And that would be to give you a number line All right, so they will give you this, and then they're going to ask you to write the conjunction statement for a variable x expressed by this graph. Okay, so let's do it. So what would x have to be if it's going to fall on this blue line, this blue graph on the number line? Well, if we're looking at that area, what is it? Well, it's an area that's greater than a -2, but not equal to a -2, right? So the x has to be greater, but, greater than a -2, right? I wouldn't say greater or equal than, because to do so would say that x might be equal to a -2, which it can't be equal to a -2. That's what this hollow circle is telling us. All right, so that's what x is greater than. Now over here, we would say that x is less than 4. But we could also say that x could be equal to a 4. That's what this solid dot is telling us. So we'd have to say x is less than or equal to a 4. Okay, and then that would be the conjunction expression that would be equivalent to this graph right here. Okay, very good. So really that's all there is to this. It's not very complicated. It's just kind of combining a couple of inequality statements, and we've learned those before. So it should be pretty straightforward. Go ahead and try these on your exercises today, and study what a conjunction is for homework tonight so that you know that definition. And sometimes it's good to throw an example into your study notes too, kind of showing what that definition actually means in a worked out example with all the steps. Excellent. All right, well, we will stop here, and I will see you tomorrow.